So good afternoon, everyone, and welcome to this lecture number 6. And I think we will continue what we were doing in the morning class, and we will continue with the transient state. As I told you, we are dealing with the charging and discharging of capacitor. Now, just to bifurcate into different stages, I can call the first stage as the initial stage. There is the capacitor, let us say, is initially uncharged. There is a resistor. Every wire has resistance, so even if I don't have any resistor, whatever wire we have, it will have some resistance. That will be the resistance of the circuit. This becomes an RC circuit. I put the switch on. The initial stage is the stage where the switch is just switched on. Then when the switch is switched on, the capacitor starts to get charged. When the capacitor is getting charged, that stage is known as the transient state. And in this case, the capacitor is charging, so it is transient charging state of the capacitor. The charge Q and the voltage V of the capacitor and the current in the circuit, the voltage drop across the resistor, everything would remain, would keep on changing with time because the charge on the capacitor is going to change. Now once you put the switch and after a long time, and again this long is a relative term, what do you call long? 1 year may be long, 1 billion years may be long, or even 1 second can be long, depending on how your reference is. If your reference is micro or nanoseconds, compared to micro and nanoseconds, even 1 second is a very long time. Compared to 1 second, 1 year is a very long time. Compared to 1 year, 10 billion years is a very long time. So it all depends on, after a long time, what will happen, the capacitor will get completely charged, and we call that charge as the steady state charge of the capacitor. We can call it as Q naught, and that is the charge on the capacitor that we were calculating till now. That was equal to C into V naught, where V naught is the final potential across the capacitor when the battery is connected. Do we understand this?
Yes, sir.
That is the final charge on the capacitor. That is also known as the steady state charge, or steady state, or the steady state value of charge on the capacitor. Why it is known as the steady state? Because after this, the charge on the capacitor is not going to change. Everyone understands what I have said up till now?
Yes, sir.
This transient state is known as the charging state of the capacitor, and the capacitor is getting charged during this time. When the capacitor is getting charged, when the capacitor is getting charged, that is known as the charging state. So now let us go through it quickly. The charging of the capacitor, and if I draw a circuit, now this circuit would have both charging and discharging combined together. So what I'm going to do is I'm going to show you this. Now initially what I will do, I will connect these 2 points I will connect at time t is equal to 0. Do we understand this? At time t is equal to 0, this switch is made. When this connection is made, what happens is that the charge on the capacitor keeps on changing. If I say that the charge on the capacitor at any given time is Q, this charge on the capacitor at any given time Q can be written as C into E into 1 minus e raised to the power minus t by RC. That is how the charge on the capacitor keeps on changing. I can also write this in this fashion: Q is equal to Q naught 1 minus e raised to the power minus t by RC, where this Q naught is the steady state charge on the capacitor. Steady state charge on the capacitor, that is happening when time becomes very large, when time is infinity, and this steady state value of charge is C into E. Do we understand this?
Yes, sir.
Instead of this RC here, I can write this, in place of RC I can write tau. This tau is equal to RC, and this is known as the time constant of the circuit. This is how the charge on the capacitor keeps on changing, and this is how it varies as a function of time. And as you can see, this is an exponential equation, and therefore the equation looks like this. When I put the value of time as 1 tau, the charge on the capacitor becomes 63% of the of the final charge or the steady state charge. Do you see this?
Yes, sir.
When time is put as 1 tau or 1 time constant, then the charge on the capacitor becomes 63%. The charge on the capacitor becomes 63% of the final charge or the steady state value of or the steady state value, and this is known as the time constant of the circuit. Time constant of the charging circuit is the time taken by the capacitor to increase its charge from 0 to 63% of the maximum value. Do we understand this?
Yes, sir.
This process is known as the charging of the capacitor. Everyone understands this?
Yes, sir.
Anyone having any doubt on this?
No, sir.
At time t is equal to 0, the switch is put to position number 1 and the capacitor starts to get charged. At any time after that, the charge on the capacitor is given by this formula. I'll give you 2 minutes to note this down. Everyone understands this? Yes or no?
Yes, sir.
Well, this formula only gives you the charge on the capacitor as a function of time, but that is not the only thing that can be asked. They can ask you the potential difference across the capacitor as a function of time. If they ask you that, you can give it by this straight away formula. V is equal to V naught e to the 1 minus e to the power minus t by RC, where V naught is the battery voltage. Do we understand this?
Yes, sir.
If they ask you the value of electric field across the capacitor as a function of time, you can also write the formula of electric field. Electric field will be equal to E naught, the original electric field, 1 minus e raised to the power minus t by RC. Do you understand this?
Yes, sir.
Now, many a times they are, apart from asking you the charge and the voltage, they can also ask you the current in the capacitor as a function of time, or current in the circuit as a function of time. To find the current in the circuit as a function of time, what you got to do, you just need to differentiate q with respect to t. Do we understand this?
Yes, sir.
We just need to differentiate q with respect to t, and if you differentiate q with respect to t, you will end up with like this: I is equal to I naught e raised to the power minus t by RC, where I naught is the maximum current and that maximum current is E naught by R. Do we understand this? E naught or E or I should not write it as E naught, I should write it as V naught by R, because we are using V naught for voltage. V naught by R. Do we understand this?
Yes, sir.
If I draw the graph between current and time for charging circuit or discharging circuit we have not done, but we will do it when time comes. I mean, just after that we can draw the graph here together. The graph would again be an exponential graph. Do we understand this?
Yes, sir.
The graph would be an exponential graph, and the graph would look like this. Now I can define the time constant from here as well. From this graph also I can define the time constant. From this graph also I can define the time constant. From this graph also I can define the time constant. And the time constant from this graph can be defined as the time taken by the current to rise from 0 to 37% of its maximum value. Do we sorry, from maximum to 37% of its maximum value, because at time t is equal to 0, at time t is equal to 0, current is I naught. At time t is equal to infinity, current is 0. At time t is equal to 1 tau, current is 0.37 times of I naught. Do we understand this?
Yes,
Here
sir.
if you put time as 1 tau, current will become 37% of its maximum value. Do we understand this?
Yes, sir.
Everyone gets this? The formula for everything? I'll give you 2 minutes to note this down. Now we can move ahead and see a very important thing in this particular case. We have seen that I've written here. If we look at the formula of current for current in the circuit when capacitor is charging, this is the formula. Do we understand this formula? I is equal to I naught e raised to the power minus t by RC. Do we understand this formula?
Yes, sir.
Where this I naught is the maximum current, which is nothing but equal to the battery divided by R. Now at time t is equal to 0, if you see the current is maximum, yes or no?
Yes.
And at time t is equal to infinity, after a long time, this current becomes equal to 0. Now I can understand this thing in a different way in terms of what capacitor is doing to this circuit. Now, when I'm saying this time t is equal to infinity, this actually infinity here could be as small as 1 second. The time that the capacitor takes to charge is very less. It's maybe even in milliseconds and microseconds that the capacitor gets completely charged. Remember, the capacitor never gets completely charged because it's an exponential curve. An exponential curve never reaches its maximum value. It always tends towards its maximum value. But for all practical purposes, 99.99% of the maximum charge of the capacitor, we can charge it to 99.99% in less than a minute, even in some milliseconds. So even if I keep the battery connected to a capacitor even for 1 second, that 1 second can be taken as infinite time. Do we understand what I'm saying?
Yes, sir.
So basically, as soon as I connect the capacitor to a battery or a cell, almost instantly, it's not almost instantly, it takes some time, milliseconds or microseconds, to get 99.99% charge. During that small time, when the capacitor is getting charged, it is known as a transient state. At that time, the current is flowing through the capacitor. But as soon as the capacitor gets charged, which is almost instantly, the current in the capacitor becomes 0. Now, I can think of this in terms of something different. I can think it of as capacitor being acting as a variable resistor in a circuit. Well, what do I say? What do I mean when I say capacitor behaving as variable resistor? Initially, as soon as we put the switch on, the resistance, the, the resistance of the capacitor. Remember, capacitor does not have a resistance. But if I take this capacitor as a resistor, I can say that initially, when the switch is switched on, stage number 1, the capacitor is behaving as it is not present in the circuit. The circuit behaves as short circuit, capacitor is not present. Instead of a capacitor, you can draw a straight line. This capacitor behaves as a short circuit. In whatever branch you have put this capacitor, it behaves as a short circuit as soon as the switch is switched on. Do you understand what I'm saying here?
Yes, sir.
It behaves as it is not present. Now, it is behaving as it is not present, but when you put the switch on, the charge on the capacitor is 0. As time goes forward, the charge on the capacitor keeps on increasing. As the charge on the capacitor keeps on increasing, the current in the circuit goes on decreasing. You have seen the graphs, yes or no?
Yes, sir.
Charge on the capacitor is keeping on increasing and current in the circuit is keeping on decreasing. So I can think it of as like this. Charge of the capacitor is increasing, so resistance of the capacitor is increasing at time t is equal to infinity, which can be even 1 second. The resistance of the capacitor becomes how much? It becomes infinite, or capacitor behaves as OC. In whatever branch this capacitor is put, that branch will start to behave as open circuit and it will not allow current to flow. That means at steady state, that means at steady state, capacitor behaves as open circuit. And therefore, in whatever branch this capacitor is put, that branch cannot have any current flowing through it and it behaves as an open circuit. So whenever in a question you find capacitor and a resistor put and it is said that the capacitor is in steady state, you can understand and imagine that understand and imagine that that branch is open circuit and no current is going to flow through that branch. Do we understand this?
Yes, sir.
Everyone has understood this?
Yes, sir.
I'll give you 2 minutes to note this down. Once you are done, please let me know. Everyone got this?
Yes, sir.
Okay. Now let us see how we are going to apply this. So first, let me emphasize on these things. Okay. I'm going to do is me start with some questions here. Remember, whenever they are asking you any question on the transient state, you must understand that in that transient state, the charge on the capacitor will be varying exponentially, and therefore, whatever answers you are going to get, they would be in the exponential form. Do you understand this? Whatever answers you are going to get, those answers would be in exponential form, and we might not be able to find out the complete answer because for to finding out the complete answer we must be knowing the e raised to the power wale terms or log of e raised to the power of or natural log of something which might be a bit let us start with this simple question. And remember, you might not get the complete answer. You may get the answer as ln of something or ln of this thing. You can only give me that answer up till there, and I will understand that you have understood the question. The capacitor of capacitance 100 microfarad is charged by connecting it to a battery of 12 volt and internal resistance. So the resistance of the circuit is 2 ohms. Find the time constant of the circuit. Find the time taken before 99% of the maximum charge is stored. I'll give you 2 minutes to give me the answer. You can give your answer in terms of ln of something. Do we understand this?
Yes, sir.
So how are we supposed to get this? First of all, the simplest thing that you can do is to find out the time constant of this. The time constant of this is simply equal to R into C. Yes or no?
Yes, sir.
So that becomes 200 microseconds. 200 microseconds. Remember, 200 microseconds. Do we understand this?
Yes, sir.
Now I have to find out the time taken so that it becomes 99% of the final charge or the steady state charge. Q is equal to Q naught 1 minus e raised to the power minus t by tau. Yes or no?
Yes, sir.
This is 0.99 times Q naught. So 0.99 times Q naught will be equal to Q naught into 1 minus e raised to the power minus t by 200 microseconds. The answer you will get will be in microseconds. Do we understand this?
Yes, sir.
Now, if you just solve this, what will you get?
That is
You will
200
you
ln
will get, yes,
200 ln 100 is
0.99 will be equal to 1 minus e raised to the power minus t by 200. Yes or no?
yes, sir.
So I can get minus t by 200 will be equal to ln of 0.01. Yes or no?
Yes, sir.
From here you will get the value of t. Ln of 0.01 will be negative, so negative negative will become positive, and the value of time after putting this is 0.92 milliseconds. So you can see in 0.92 milliseconds it actually gets 99% charge. So even infinity, 1 second may be infinity. Do we understand this?
Yes, sir.
Or it has gone above that saying bye bye, bye bye, bye bye, bye bye, I'm going, bye bye, bye bye. Huh? Bye bye,
Understood, sir.
bye bye.
Understood, sir.
So any question that comes in this category, you may not be able to solve it completely unless and until you are given the value of e or e square or whatever. So most of the question, if it comes, they will give you that value. So let us not waste our time in getting to that value. And I'll give you one or two more questions on this. Okay, this one, do it fast. Again, we might not get the complete answer, but up till whatever stage you can take it and let me know the final answer for this one. A capacitor is connected to a 12-volt battery through a resistance of 10 ohm. It is found that the potential difference across the capacitor rises to 4 volt in 1 microseconds. Find the capacitance of the capacitor. You have 2 minutes to give me the answer.
ln 3.
So how are we supposed to do
Sir,
this?
is it 10 ln3?
So I will put the formula for the voltage across the capacitor. V is equal to V naught e raised into 1 minus e raised to the power minus t by RC. Voltage is given as 4, that must be equal to final voltage is 12, 1 minus e raised to the power minus t by RC. 1 by 3 is equal to 1 minus e raised to the power minus t by RC. Shall I go ahead or you will be able to do it from here? So you will get,
We have done the same, sir.
no, you have not done the same. You will get T by RC as ln of 3 by 2.
Sir, same thing I got, sir.
Yes. So R into C will become T divided by ln of 3 by 2. That implies C becomes T divided by R ln 3 by 2. This was not the answer that you gave, isn't it? This is the answer. You have to find the capacitance, not anything else. Do we understand this or this has gone above our head saying bye bye? Bye bye, sir. I'm going bye bye. I'm going bye bye. I'm going bye bye.
Understood, sir.
Bye bye.
Understood, sir.
Okay. Charlie, move ahead in life.
Yes, sir.
Now you have uh, condition like this. You have two capacitors C1 and C2 connected across a battery of EMF E, and a total resistance of the circuit is R. You have to find out, if I say the questions, Question number 1, you have to find out the time constant tau of this circuit. Number 2, you have to find out Q1, Q2. Q1 and Q2 are the charges on the capacitor. Do we understand this?
Yes, sir.
Q is the charge flowing through the battery. Do we understand this?
Yes, sir.
V1 and V2. Will the current be same or different?
Same, sir.
Current as a function of time. All of these things, if they are variables, you have to find them as a function of time. I hope you understand the question. I'll give you 2 minutes to give me the answer. So how are we supposed to do this? Whatever charge is flowing in the circuit, the same charge will be deposited here. All the capacitors are uncharged, and the same charge will be deposited here. Yes or no? So Q1, Q2 and Q are all going to be same because the current flowing in the circuit is going to be same. Do we understand this?
Yes, sir.
Now what you can do is, we don't know the formula for two capacitors, but we know the formula for one capacitor if it is connected to one resistance. So what I'm going to do is, I'm going to change this circuit from this circuit to this one. And I hope you understand what is this circuit. Yes or no? No or yes?
Yes, sir.
That will be C equivalent, and this C equivalent is C1 C2 upon C1 plus C2. Do we understand this? So the time constant of this circuit will be how much? C
R into C1,
equivalent
C2 by
multiplied
C1 plus C2.
by R. Do we understand this?
Yes, sir.
This will be equal to Q naught Q naught into 1 minus e raised to the power minus t by tau. Do we understand this? This Q naught will be equal to C equivalent. Both the charges will be same. Do we understand this? Into V. It's not V here, it's E. Do we understand this?
Yes, sir.
Yes, sir or no, sir, sir?
Understood, sir.
To find the value of V1, you can find it from Q by C1. Do we understand this?
Yes, sir.
To get the value of V2, you can find it from Q by C2. Yes or no?
Yes, sir.
To get the value of I, you can differentiate Q with respect to time. You don't need to do this. You can simply write this as I naught e to the power minus t by tau, where I naught will be equal to E divided by R. Yes or no? No or yes? Huh?
Yes, sir.
Do we understand this, or this has gone above our head saying bye-bye?
Understood, sir.
So basically, if you understand one thing, the other things will come automatically. Do we understand this?
Yes, sir.
Have you noted it down?
1 minute.
Let me know once you are done. Then we have this question, same thing. Q is the charge in the circuit. You have to find the value of Q. Q1 and Q2 are the charges on this capacitor. You have to find the value of Q1 and Q2. You have to find the time constant of this circuit. I is the current in this branch, main branch. I1 will be the current in this branch, and I2 will be the current in this branch. They will be different, yes or no?
Yes, sir.
Once you get the value of one thing, the other thing should come automatically. I hope you understand the concept. I'll give you
Yes.
2 minutes to give me the answer for this one. So first of all, tell me the time constant of this circuit. Tau.
R into C1 plus C2, sir.
R into C1 plus C2. Well done. Then tell me the charge Q in the circuit.
C1 plus C2 into E into 1 minus E part T minus tau, sir.
Do we understand this, or this is going above our head saying bye bye? I'm going, sir. Bye bye. I'm going, sir.
Understood,
Bye
sir.
bye. Huh?
Understood, sir.
Good. Q1.
Q1 equals to C1 E into 1 minus E power minus T tau, T by tau.
Very good. You can find it on this way straight away. This potential is applied across these two branches and they are in parallel. Then you can put it that way also. But remember, your tau will be R into C1 plus C2. You can get the other results, yes or no? To
Yes,
get the
sir.
value of I1, you will differentiate this equation. Do we understand this?
Yes, sir.
To get the value of I2, you will differentiate the equation of Q2. To get the value of I, you will differentiate this equation. Do we understand this, or this is going above our heads? Saying bye bye.
Understood, sir.
Since you have understood this, then this is the time that you can do this one. Find the time constant for the given circuit. R1 is this, R2 is this, C1 is this, C2 is this. I'll give you 2 minutes to give me the answer. 6 microseconds is the correct answer. You have to just find the effective capacitance of C1 and C2. I think that will be 2 microfarad, yes or no?
Yes, sir.
And you have to find the the parallel combination of 4 and 12. Parallel combination of 4 and 12, I think, is 3, yes or no?
Yes, sir.
3 into 2, 6 microseconds would be the. Do we understand this? Yes or no?
Understood, sir.
Or bye bye?
Understood, sir.
Bye bye?
No, sir.
We can move on. And solve this question. This is a switch. This is a distance R1. This is the distance R2. This is capacitance C. This current is I. This current is I2. And this current is I1. At time t is equal to 0, the switch is switched on. So we start the time when the switch is switched on. As soon as you put the switch on, tung. As soon as you put the switch on, tung. You have to tell me the value of I, I1 and I2. As soon as the switch is switched on, everything is initially uncharged, the capacitor is initially uncharged. You have to tell me the value of I, I1 and I2 as soon as the switch is switched on. Do we understand the question?
Yes, sir.
At time t is equal to 0, you have to tell me the value of I, I1 and I2. I'll give you 2 minutes to give me the answer. So tell me the value of I1 first.
R2 by R1, R2 by, sorry, R2 E by R1 into R.
Aram se, aram se. Take a deep breath. Open your eyes. Think. And then give me the answer. Yes. What is the value of I1? I1. At time t is equal to 0, when the switch is switched on, how does the capacitor behave? How does the capacitor behave?
Short circuited, sir. E by R1, sir.
Yes. It is behaves like it is not there. If it is not there, take it out, tongue, put a straight line. It is a simple question. R1 and R2 are in parallel, battery E, and the value of E1 would be simply I1 will be E by R1, I2 will be equal to
E by R2, sir.
E by R2, and I will be equal to I1 plus I2. Do we understand this?
Yes, sir.
Or this has gone above our head. Saying bye bye. Bye bye.
Understood, sir.
After a long time has passed, find the value of I, I1 and I2. Two minutes you have. Then tell me the answer.
Sir, I equals to I2 equals to E by R2, sir.
In that case, I1 will be infinite. I1 will be 0 because it will behave as open circuit. Yes or no?
Yes, sir.
And I will become equal to I2 and that will become E by R2. Do we understand this? Or this is going above our head saying bye bye?
Understood, sir.
Comes the third. Find the steady state value of charge. I may not call it like this. This is the correct way of saying this. Find the steady state value of charge on the capacitor. Book or question may simply say, what is the steady state charge on the capacitor? What is the final charge on the capacitor? Up till what amount the capacitor will get charged? What is the charge on the capacitor? Two minutes you have to give me the answer. E into C is the correct answer. Now, whenever you see a question and you see resistors and capacitors, and then they ask you the charge on the capacitors, just take a deep breath and listen what you got to do. To find out the charge on the capacitor, which is the steady state charge on the capacitor, you have to find out the potential difference between these 2 points, which is the potential difference across the capacitor. Yes or no?
Yes, sir.
Now, since the capacitor has come in steady state, there will not be any current in this branch. I1 is 0. Yes or no?
Yes, sir.
So the potential difference between these 2 points, current is 0, remember, is same as the potential difference between these 2 points. Yes or no? Because there is no current in the circuit.
Yes, sir.
So basically, you have to find the potential difference between point A and B after a long time. Yes or no?
Yes, sir.
Long time or short time, the potential difference between A and B is how much? There is no resistor here in between. Downwards, there is no resistor here. So the potential difference between A and B is how much?
E, sir.
It is always equal to E, whether it is at 0 time or infinite time, it is always E. So the final potential difference across the capacitor would be E. And therefore, the charge on the capacitor will be E into C. Do we understand this, or this has gone above our heads? Seeing bye.
Understood, sir.
Bye bye. Bye bye. Bye bye. Do we get this?
Yes, sir.
The last question, the most difficult question that can be asked is, what is the time constant of this circuit? What is the tau of this circuit? Now, tau of this circuit is very simple because the upper wala resistance R2 is not doing anything in the circuit. Yes or no? The capacitor is simply getting charged by the resistor R1. Yes or no?
Yes, sir.
Yes or no? The resistor R2 is present or not, that does not make any difference to our life. So the time constant of this circuit is simply equal to R1 into C. Do we understand this?
Yes, sir.
There is one more way of doing this to find the time constant of a circuit. How do you find the time constant of the circuit? To find the time constant, step number 1. Step number 1. Short circuit. Oops. Step number 1. Short circuit battery. You short circuit the battery. Step number 1. Step number 2. After short circuiting the battery, find R equivalent between the points A and B. Do you understand which points A and B I am talking?
Yes, sir.
Yes. You have to find out after short circuiting the battery, you just find out the equivalent resistance between point A and B, the time constant of the circuit. The time constant of the circuit will be equal to R equivalent multiplied by C. This R equivalent is also known as Thevenin's resistance because the circuit is known as Thevenin's equivalent circuit. So this resistance is also known as Thevenin's resistance. So this is the formula, this is the way to find out the time constant of the circuit. If I apply this way also here, as soon as I short circuit this entire green part, the resistance R2 will get short circuited, yes or no?
Yes, sir.
The effective resistance between point A and B will be how much?
R1.
Do we understand this?
Yes, sir.
Therefore, the time constant is R1 into C. This way you can find out the time constant of any circuit of this nature. You understand this, yes or no?
Yes, sir.
Everyone understands this? Take a deep breath, see it for 3 minutes. Once you are done, then I will give you one question in which we will ask everything that is possible. Everything that is possible. I have asked everything in this question that is possible. I'll give one more question and I'll ask again everything which is possible. If you can do that, that means no question in this particular class can trouble you. I'll give you 2 minutes. Go through this. Once you are done, let me know. And this is the circuit. The first question is at time t is equal to 0, you have to tell me the value of I, I1 and I2. The resistances are R and R1. Capacitor is C1 and the switch is switched on at time t is equal to 0 seconds. What is the value of I, I1 and I2? And the answers are
Sir, I equals to I1 equals to E by R plus R1.
I will be equal to I1 and that will be equal to E upon R plus R1 and I2 will be equal to how much?
0, sir.
You have to take deep breaths. Whenever a question comes, take a deep breath. Close your eyes for 5 seconds, then open it. See the question again, and then give me the answer again. Something wrong? Or everything okay? At time t is equal to 0, how does the circuit behave? How does the capacitor behave?
Okay. Sir, R1 is short circuited.
Yes. So, can current flow in R1?
No, sir.
No, my dear friend. So, that is the wrong answer. So, I1 becomes equal to 0. Take deep breaths. And I becomes equal to I2 and that becomes equal to E by R. Do we understand this?
Yes, sir.
It has gone above our head saying bye bye.
Understood.
Chalo, we understand this. So we move ahead. At time t is equal to infinity. Long time has passed. Long time has passed. What is the value of I, I1 and I2?
Sir, I2 is equals to 0, sir.
I2 equals to 0.
And I1 equals to I equals to now it's E by R plus R1.
Do we understand this or it has gone above our head saying bye bye?
Understood, sir.
Pakka?
Yes, sir.
Pakka? Okay. Find the charge find steady state charge. Let me call it Q naught, maximum charge, steady state charge on the capacitor. What is the steady state value of charge on the capacitor? Take deep breaths. Then open your eyes. Then look at the question and then give me the answer. I'll give you 2 minutes to do that. So how am I supposed to do this?
Sir,
I have
it
to
is
find the
V1 into C,
potential.
sir.
Yes?
V1 into C, sir.
I have to find the potential difference between these 2 points A and B. Yes or no?
Yes, sir.
No current flows in this branch. So this is same as the potential difference between these 2 points A dash B dash. Yes or no?
Yes, sir.
After a long time, the potential difference between A dash B dash. What is the potential difference between A dash B dash after a long time?
I1 R1. Sir.
Yes. And that multiplied by C would be your steady state value of charge. So what is the steady state value of charge, my dear friends? Q naught will be equal to E into R1 divided by R plus R1 times C. Do we understand this?
Yes, sir.
It has gone above our head saying bye bye.
Understood, sir.
Bye bye. Bye bye हो गया. Find tau of this circuit. Tau of this circuit. Tau. What is the tau of this circuit? What is the tau of this circuit? Any idea? No idea. Get idea. Bye bye. Bye bye.
Sir, that depends on R1 and R, sir.
What is the value of tau? Question remains the same. And the value of tau is, you have to find R Thevenin or R equivalent. R Thevenin between these 2 points by short circuiting the battery. So battery goes away. In between these 2 points, we open the circuit and we find out the equivalent resistance between these 2 points. What is the equivalent resistance between these 2 points? Battery is short circuited. What is the equivalent resistance between these 2 points? The battery is short circuited. What is the equivalent resistance between these 2 points? The battery is short circuited. What is the equivalent resistance between these 2 points? The battery is short circuited. And the answer is?
R1 R by R1 plus R.
They are in parallel. So the answer is R1 upon R plus R1. Was it so difficult?
That means we should.
Therefore, your tau becomes R Thevenin multiplied by C. And that is the answer. Do we understand this, or this has gone above our head saying bye bye? I'm going. Bye bye, sir. Please forgive me.
Understood, sir.
I'm going. Bye bye, sir. Please forgive me. Then comes the last question. And now if you put your head, heart and soul together, you can now find Q as a function of time, that transient circuit curve equation. What will be the value of Q of the charge as a function of time? Everything is there in front of your eyes. And the answer for this one is time is running out. Q as a function of time.
Sir, it is
Q as a function of time. Yes.
E R1 by R1 plus R2 into C into 1 minus E power minus T by tau.
Q is equal to Q naught into 1 minus e raised to the power minus t by tau. Everything we have calculated. This is my Q naught. Dong 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 dong. This is my tau, dung 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 dung. This is my RThevenin, dung 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 dung. Everything is there. So now we know the value of every L thing. If someone asks you find I2 as a function of time, you just differentiate this Q as a function of time. Do we understand this?
Yes, sir.
That is your answer. You get this? So once
Yes.
you understand this, you should be able to find anything, any question that comes that asks you to find out the charge on the capacitor. They are asking you the steady state value of charge. You just find the potential drop across the capacitor and multiply it by C. This is a question from SCV. Give me the answer fast. You have 2 minutes to do the needful. So my dear friend, what is the answer for this one?
1 minute.
1 minute, sir. This question, my dear friends,
Sir, 6 microcoulombs.
is exactly the same as this question. Do we realize this?
Yes, sir.
Same. The value of C is 6 microfarad. We realize this? The value of this R1 is 10 ohms and value of this R is 20 ohms and this battery is 2 volt. Do we understand this?
Yes, sir.
Same question. Nothing has changed. Yes or no?
Yes, sir.
So we can solve this entire question. Do we understand this? Yes or no?
Yes, sir.
So I will leave it to you to solve it and we move on to the last heading of this, discharging of capacitor. Discharging of capacitor. Now to charge the capacitor, now to discharge the capacitor, we need to charge it first. Yes or no? Yes or no?
Yes, sir.
So here we come back to the original circuit that we had taken. To charge the capacitor, we had put the switch to switch number 1. Do we understand this?
Yes, sir.
We again do the same thing. We put the switch to switch number 1 and keep the capacitor charged. Charge the capacitor. After a long time, the capacitor becomes charged. We disconnect the switch 1. The capacitor is now charged. And now we connect the switch at point 2 at time t is equal to 0. Do we understand this?
Yes, sir.
After charging the capacitor, we are putting the switch to switch number 2 and then we find out the charge on the capacitor. The charge on the capacitor will be Q0 into 1 minus e raised to the power This was the charging thing. Now for discharging, the equation looks like this. Q0 into e raised to the power minus t by r. Let me call this one just to make things different. Let me call this one as R1 and let me call this 2 as R2 so that you understand the difference. Now here, when the capacitor is getting discharged, it will become R2 into C. Do we understand this?
Yes, sir.
Where this Q0 was the maximum value of charge and that was E multiplied by R1 because it was charging from a different resistor and getting discharged by a different resistor. Do we understand this? Do we understand what I'm saying here?
Yes, sir.
In this circuit, they have drawn both resistance as same. Both resistance can be same, they can be different. So we can do the case of different one. Once you understand the case of the different one, you can understand the case for the same one. Yes or no?
Yes, sir.
The charge will go down exponentially and after one time constant, the charge will become 37%. Do we understand this?
Yes, sir.
Do we understand this, everyone? I'm not getting voices. Do we understand this, everyone?
Yes, sir.
In one time constant, the charge will become 37%. Remember, the Dimension formula of R into C is the dimension formula of time. And 1 by RC is the dimensional formula for frequency. This question has come many times in many attempts in many exams. Do we understand everything that we have that I have written here? Yes or no?
Yes, sir.
Everyone understands this?
Yes, sir.
Everyone understands this?
Yes, sir.
Note it down. This is discharging of capacitor. The dimensions of R and C are not those of time. Therefore, the dimension of 1 by RC must be of frequency. The potential difference across the capacitor will be V naught e raised to the power minus t by tau. The current will be I is equal to I naught minus I naught because it will be in the opposite direction. If the charging current was like this, so this plate of the capacitor will get positive, discharging current would be like this. Do we understand this? Therefore, this negative sign comes. Do we understand this?
Yes, sir.
Charging and discharging current are in the opposite direction. I'll give you 2 minutes to note this down. Then this is the next question, sir. Again, we might not get the complete answer, but we can get to the answer up till ln or whatever. That is good enough. A capacitor is charged to 50 volt is discharged by connecting the two plates at time t is equal to 0. If the potential difference across the plate drops to 1 volt at 10 milliseconds, what will be the potential difference at 20 milliseconds? You have 2 minutes to find out this one. 1 by 50 is correct. Well done. So how are we supposed to do this? We just have to apply the formula V is equal to V naught e raised to the power minus t by tau. Yes or no?
Yes, sir.
In first case, I am given that V is 1 volt. So 1 is equal to 50 e to the power minus t by tau. And time is given as 10 milliseconds. Yes or no? Let me write the time as 10. So it will be minus 10 by tau. Yes or no?
Yes, sir.
Then you have to find out the value of V, which will be equal to 50 e to the power minus 20 by tau. Yes or no?
Yes, sir.
So I can write it as 50 e raised to the power minus 10 by tau squared. Yes or no?
Yes, sir.
So, and that we already know. Yes or no? E raised to the power minus t by tau is 1 by 50. So this becomes 50 multiplied by 1 by 50 ka squared. Yes or no?
Yes, sir.
So the answer would be 1 by 50, 0.02 volts. Everyone understands this, or this has gone above or at saying bye-bye?
Understood, sir.
Everyone got this?
Yes, sir.
One more on this. Again, you might not get the complete answer, but you can get it to the point where you get ln and all those things. And I will the electric field between the plates. It's a question on electric field. Doesn't matter. If you know one, you know everything. The electric field between the plates of a parallel plate capacitor of capacitance 2 microfarad drops to 1/3 of its initial value in 4.4 microseconds. When the plates are connected by a thin wire, find the resistance of the wire. You have 2 minutes to give me the answer. So how are we supposed to do this? We just have to apply the formula E is equal to E naught e raised to the power minus t by RC. Yes or no?
Yes, sir.
This is E naught by 3 will be equal to E naught e raised to the power minus t by RC. From there you can calculate the value of R. Yes or no? No, yes.
Yes, sir.
Everyone understands this?
Yes, sir.
And let me take you back to the same question and just finish this question. We had done up till here in this question. We had found out the charge on the capacitor as a function of time when the capacitor was getting charged. Do we understand this?
Yes,
Do we
sir.
remember this question?
Yes, sir.
Now, after the capacitor getting charged, the switch is switched off. The switch is now again, the switch is switched off at time t is equal to 0. Do we understand the question? Now the question starts again.
Yes, sir.
Capacitor had been charged and now the switch is put on. What is going to happen now?
The battery gets discharged.
The battery does not get discharged. The capacitor gets
Capacitor.
discharged. What is the time constant of the discharging capacitor? Tau discharging. What is the tau discharging?
R1 into C, sir.
R1 into C. Do we understand this? Yes or no? This has gone above our head. Saying bye bye.
Understood, sir.
Can you tell me the charge on the capacitor as a function of time when it is getting discharged?
Sir,
The charge on the capacitor as a function of time now.
Q equals to Q naught e power minus T by R1C.
Minus T by R1C. Where what is this Q naught? This Q naught is still your original Q naught. Do we understand this?
Yes, sir.
And this is how charging and discharging come together. As you can see, the time constant of the charging circuit is completely different and time constant of the discharging circuit is completely different. The time constant of the discharging circuit is R1 into C, whereas the time constant of the charging circuit is R into R1 upon R plus R1 into C. Do we understand this?
Yes, sir.
Well, that finishes up this part of this chapter. We are done with capacitor. We are not going to come back to it. Maybe one more thing is left. We might be doing it. Once we are done with current in the next class, we will start and try to wind off current in one class in 3 hours. Not much is left because circuits are already done. We are left with only other things apart from the circuits. So we will try to cover them in the next class. Take care and God bless all of you. Bye bye. Everyone has understood what we have done in today's class?
Yes, sir. Sir, what will be doing tomorrow?
Current.
Current. Okay, sir.
Take care. God bless you all.
Bye, sir. Have a good day.
Bye, beta.